Hello, everyone. Thank you for joining us today. My name is Danielle Parker, and I'm the Executive Director of the Preservation Alliance of West Virginia. Today's webinar is entitled Laser Scanning for Historic Preservation, and I'm joined by Paula McClain and Michael Boyce, who both work for the Mills Group architecture firm that's based in Morgantown and Wheeling. And they will be doing a really great technical talk for us today. And if you have any questions throughout the presentation, you can submit those either through the chat bar or the questions tab, and we'll answer those at the end of the presentation. And if you're having any kind of technical difficulties, you can send a chat message to me as well, and I'll help you deal with that, whatever issue you're having. So I'm going to hand it right over to Paula and Michael. Thank you guys so much for being here with us today and for doing this presentation.
Thanks, Danielle. Yeah, we're excited to be here. So as Danielle said, we are, let me advance the slide here. There we go. Mills Group is celebrating our 15-year anniversary this year. Michael Mills founded Mills Group in Morgantown in 2005, and then in 2013, we were lucky to add Vic to our team, and he heads our Wheeling office. Do a lot of as-built and new construction, but we really pride ourselves in our work in the preservation field, and we're excited to share this new technology with you today. I'm with Michael Boyce, who's our architectural design associate and kind of our scanner expert for the office. So he's got all of our technical information. He's here with me today. And that's me. I'll also be talking for some of this presentation. I just wanted to kind of talk about the history of this technology and where we've come from, because we've come a long way in a pretty short amount of time. Basically, Ben Casira is the sledgehammer that started the laser scanning movement in the United States and really internationally. He was born in Mosul, Iraq in 1940, and then he moved to Chicago in at 24 to get a degree in structural engineering. And then in 68, he and his wife Barbara moved to San Francisco, and he started working for an engineering firm. But he found that they weren't like pushing the envelope technologically as much as he wanted them to. And he was really interested in doing like computer graphics and more visualization. So this is kind of the timeline of how this all happened. Really between 1973 and 2001 is when laser scanning took off. The concept and the initial design development happened in 1973 under a company of Casira's named Signa. And in 1997, the first prototype was rolled out after decades of working on this with laser experts and engineers, and actually a team of grad students at UC Berkeley in their computer science division. Their first prototype was actually in a Volkswagen van, and it took up the entirety of that van. It was pretty large, and it captured 30 points per second of data essentially. So it threw out these laser points and collected 30 points per second. Just to give you an idea, in comparison, today the technology that we use captures 360,000 points per second. So it gives you an idea of how far we've come even in the last like 23 years. So pretty impressive work that Mr. Casira did, in addition to work with Leica. This is something that that the Casiras kind of devoted themselves to after their acquisition by Leica. Also in 2001, obviously, the World Trade Center disaster, beginning of all of that. Ben was seeing his home site and like heritage sites that he had visited as a child being destroyed by terrorist groups. And he felt like it was really important to use the technology that he had helped develop to like save these sites or like preserve them in a digital environment, so that if anything were to happen to them outside of our control, like we would still have a record of them, and like our children could continue to appreciate and learn the lessons of these sites. So kind of the culmination of this whole thing is this project that started in 2008 called SciArc. It's now an independent nonprofit, and their whole thing is just they scan sites for free and then share them with the world. And I'm going to try to go to this really cool 3D viewer that we have. Oh, it came onto this screen. I don't know if I can get over there. Is it in the PowerPoint? All right. Well, we will include this link at the end of the presentation because this is a really cool like 3D viewer where you can literally like pan around the model that was created from this point cloud data and see in extreme detail things like the Lincoln Memorial and you know, all sorts of world famous cultural resources and like icons and historic sites. The next thing that the Caceres did with this information was to start another nonprofit organization called Open Heritage 3D. And this platform, launched in 2019, actually creates a free digital download of all of the sites that Cacera you know, scans that are relevant and that can be shared. And so people can just, anybody can go to this website and download full like point cloud 3D data of over 70 sites at this point from this website. So we will also include just like a link to this website at the end of the presentation. It's a really neat tool. So next we're going to talk about kind of our methodology, and I'm going to hand it over to Michael here.
Yeah, so I'm going to talk a little bit about what we do at Mills Group. So first off, the technology. The technology we use specifically is called point cloud scanning. This is more of a modern term for two older types of methods of 3D representation. Those would include LiDAR and photogrammetry. LiDAR is the method of using infrared lasers shot in all directions and detected by a receiver, and it works similar to the way radar does, or sonar. And then photogrammetry is the method using high definition images to build a 3D representation. So what our technology does is it takes both of these methods and overlays them on top of each other, creating an extremely accurate but also photorealistic model. So there are, I mean, numerous different companies and different types and sizes and shapes of scanners. The specific company we work with is Leica. They're definitely the leader in laser scanning in the world right now. And they offer many different sizes and types of scanners. The large one you see there is, it's an industrial size. It's one that's used for capturing huge things like skyscrapers. And then there's smaller, medium-sized ones. And the one we use is that smaller one there, which is called the BLK 360 scanner. This is the first consumer-grade 360 scanner that uses the advanced point cloud scanning methods, while also capturing separately 360 spherical images, much like the images you would see if you were in Street View on Google Maps. The scanner itself is very innocuous. It's very small. You can see it's just a bit larger than a coffee mug, but it's extremely powerful and extremely expensive technology, if I say so myself. Okay, the process. There's our coworker Stacy. You can see the size of the scanner. It just sits on a normal camera tripod, and you can carry that tripod anywhere you go. In scanning, what we do is we just carry it throughout a space, interior or out, with a certain amount of distance, keeping in mind. And we run a scan. It takes about 10 minutes to run it. And then that information is collected on the scanner. On the tripod, the scanner spins around 360 degrees twice. The first pass, it takes spherical images, and then the second pass, the laser scans by sending out up to 360,000 infrared lasers per second. It then takes those two different methods, overlays them on top of each other, and then that gives you a raw scan file. We can then take those raw scan files from all the different locations and then put it into the PC and register them or stitch them together into a full cohesive 360 model. The technology does other things. It can build floor plans for us. It can tell you the different types of materiality, which is sometimes important, and it can also tell you heat signatures. It's a feature that we don't usually use in architecture. Generally, we use this just to capture the existing conditions as they are at that moment, and then use it either for preservation purposes, displaying it graphically, or actually using it to plug it into our architectural modeling software and building concepts from the existing model. So let's talk about the results. Let me go through these and see what they are.
So this is a typical overlay of what a point cloud looks like when it's overlaid with a model that we've actually drawn in our 3D modeling software, which is, this is essentially the reason that this technology was put out was to quickly and efficiently capture, realistic existing conditions, capture things like deterioration as they are before we begin a project. So once we have the point cloud in 3D, we then model in 3D and make actual elements like walls and floors and windows that all go into these 3D models. We can also cut sections through the point cloud, which is a really great feature, particularly in existing and historic buildings that we work in throughout the state, because it allows us to, see things like sloping floors and sagging joists and, odd ceiling assemblies and things that don't always present themselves immediately in the field, just from a, in-person, boots on the ground approach. So these are both from the Masonic Lodge on Market Street in Parkersburg. This will be familiar to tour attendees of our last awards banquet in Clarksburg. This is the Maxwell residence, really beautiful 1800s home in downtown Clarksburg. This was done for a landscape study. So, even when we don't end up building an entire model or a house, a lot of times we use information from either the topographic or like the vegetative material that we're picking up with the point cloud. This is a project that Michael Boyce did. Do you want to talk about this one?
Yeah, so this is a project we were trying to get. It was, I think they were doing just interior renovation. This is the Mon Arts Center. It's actually directly across the street from the building we're in right now. It was originally the first post office in Mon County, the entire building. And then when the new post office got built, this one was turned into an arts center. So it's I believe it's a modern arts area on the first floor, along with the Black Box Theater. And then on the lower basement floor, I guess you could call it, there is a actual history museum of the Morgantown area. So it's a really cool space. Really all we did with this project was scan it, but this technology is great because even though we weren't actually able to use it for anything at that moment, down the road we'll be able to, we have this model already saved, it's already stitched together, and we can already measure from it and take images and still shots. So we can actually use this down the road if they ever need any sort of other rehabilitation or preservation work done on this.
This is a historic school in Lewisburg that we've been working on that has a large gymnasium component attached to an addition. So you can see we kind of cut this section through the point cloud through the 3D model. And really this just shows off the the scanner's ability to capture things like ceiling details and trusses and accurately represent things that we could not do without belaying ourselves from the roof, and we don't do that type of thing. So this is another great historic project that we were able to scan. This is at the Hawks Nest State Park. It's their CCC era museum building, which has since been converted into a private residence. It's a very unique shape and design and has all sorts of interesting design details, like this bracketed overlook at the end that actually, you know, faces towards the New River. And using this technology on this project allowed us to, you know, capture this unique footprint, things inside where alterations had taken place. If you look over to the left of the fireplace here, you can actually see a little seam where a former door was infilled. And we are, you know, looking at options for how we go back to our historic form there or not. And really, you know, we take hundreds of pictures as well when we do site visits, but sometimes there's like a little detail in a corner or, you know, along a floorboard that you just really need months later and you don't have it. So this technology allows us to have the whole thing essentially preserved in 3D space forever in the digital realm. You want to talk over some benefits of this technology?
Yeah. So benefits of the technology, time, obviously. Before, whenever we went to, say, record the measurements of an existing building, we would have multiple people, would have to go down, tape measure, paper and pen to sketch, sometimes even laser measuring devices that can just measure single linear distances and literally sketch out and draw the building and measure it as we're there. Sometimes this was a long, arduous process that took multiple days. Now we can have essentially one person go out with the scanner and in a matter of a few hours scan an entire multi-story building all by themselves. They don't have to worry about missing any sort of measurements. They don't have to worry about missing any photos, because as long as they walk through the entire building and scanned all the rooms, they have everything. Nothing's lost. Accuracy. The point cloud scanner, like I said, uses infrared lasers. People ask me all the time, how accurate is it? Can it have mistakes? The answer is, long story short, no, it doesn't have any mistakes. It uses lasers, and lasers are absolutely accurate. I would say the points are accurate to within less than a millimeter. I don't really even know how close it can get. The real problem comes with stitching together each separate scan with the last into a full 3D model, but if done correctly, it is extremely accurate, almost scary accurate. Safety. We don't have to climb up on any roofs. We don't have to go up on any ladders. We don't have to go into spaces that might be dangerous, like a crawl space or an attic that's just too short to get into. You just stick the scanner in there, push a button, and 10 minutes later, you have all the measurements and photos you need. And finally, versatility. That kind of wraps up the previous three. It's a useful device that we've used for multiple different reasons. Sometimes we like to use the scanner not for the scans, but just for the 3D photographs that we use to show clients. Sometimes we're scanning actually an empty site, but we just want to capture the topography of the site. So we're able to scan an empty lot, delete all the trees and everything around, and then we just have the ground itself that we can model from. So it's a indispensable piece of equipment that we use on almost every, if not every single project in our firm.
So I wanted to open it up for any questions that anybody has before we kind of wrap it up and share some resources with you all. There any
Okay,
questions?
yeah, there was one question that came in earlier, and I can read that to you. And then also some of the resources, the links that you're sharing, then I can add those into the chat for everyone, and then can also put those online for people to resource and in the email that you'll receive tomorrow as well. So the question that came in is, what modeling software do you use?
So the software we use with the actual scanner is called Recap. Overall, the company that we use all our software with is Autodesk. So Autodesk makes the program AutoCAD, which I'm sure many people have heard of. Recap is one other program specifically designed to be used with point cloud files. The scanner we use is currently the only scanner that actually works with their mobile iPad version. So the way we use it is in conjunction with the scanner on site, we use an iPad that has the Recap program application open, and then that is what is collecting the scans that we then take to the PC, plug the iPad into the PC, and then transfer those scans over to the PC's Recap. Then in Recap, after we build the model completely and it's a full 3D point cloud model, we can then transfer that over to Autodesk Revit. Revit is the program that we use in architecture to model in 3D and create all of our drawings and everything. So we can essentially use the point cloud model. I call it tracing in 3D. It's like a ghost of the building that you can stick into Revit, and then you can actually model it with solid surfaces and objects and things like that.
Thanks, Michael. The next question that we have is, do you use 3D scans to create renderings?
The 3D scans in and of themselves are kind of renderings. You can't really develop them any farther than what they are, because what you see in the 3D scan image is reality. It's literally the RGB photographic elements overlaid on top of the laser points. But what we can do is we can take that point cloud model, build a actual model in Revit, and then put that model into another program called Lumion that we then would create ground and trees and people walking around, birds flying around, and then we can render that and make that look absolutely phenomenal.
That kind of gives us the ability to do like a before and after 360-degree shot, essentially, or like a before shot and then a conceptual, 360. Mm-hmm. And then we could even, we do then like an after 360.
And I think that's the easiest way to explain it. It's a three-step process. We use the Recap and the point cloud scanner to capture the existing building. Then we put that into Revit to actually model and create our drawing documents for that building and concept design. And then we can take that Revit model and put it into Lumion, which then does the final artistic renders.
And another question has come in. Do you think Revit is better than Max or Maya?
Those are different programs altogether. 3ds Max and Maya, they're generally used for concept designing, and specifically concept designing models that are not typical. Revit is a more typical construction building construction software. You're not going to be creating, say, like the Guggenheim Museum in Revit. That's something you would use Maya or 3ds Max for. But it's hard to say which one's better. In an architecture firm, actually the answer would be Revit, because Revit not only models your building for you in 3D, it also simultaneously builds your construction documents, something that Maya and 3ds Max absolutely do not do.
Thank you, Michael, and thank you, Paula. Those are all the questions that I've received so far. So if you want to, you said you had some other comments to wrap it up.
Yeah, I just wanted to run through these resources slides real quick to share with you, which we'll share these actual links with you all. But in case you want to check out the 3D Explorer through SciArc, that's how you get to it. The Open Heritage 3D portal, we will also send you the link to. And then this we didn't really get into in this presentation, but there is LiDAR data topographically of a lot of West Virginia. You can see kind of the coverage on the blue on that map of the state, and it is publicly available and free to download if you can figure out how to use it, which is sometimes a challenge, but it can be done. And I think it's just something that people need to know is out there, because it's a really great tool. I also wanted to We put all of our projects ultimately into these walkthroughs. So
Just the images.
yeah, just the images so that you can like walk through a space in 3D. So we're gonna share this link that you all can kind of do a demo of what a walkthrough would look like. This is just kind of a hotel lobby, not a historic project, but has a good kind of flow. And then if you want to know anything more about the technology history of this, this website is really great, has more about the predecessor to Leica, which was Field Heerbroek. And please feel free to contact us if you have any questions about this technology or would like to discuss it anymore. Look forward to talking with you about it.
Great, thank you all so much. Originally, we wanted to have this as part of our conference, like so many of the other webinars we did this summer, and would have had a demonstration. So hopefully the plan is to do it next year and be able to do some kind of demonstration as well. But
Yep.
if you would like to revisit this webinar, any of the other ones, you can do so by visiting our website at pawv.org. And thank you again. I hope you all stay well, and please feel free to contact us if you ever need anything. Have a great day.
Thank you so much.
Thank you.